We're here today in Munich. We're here at the Audi Conference Center at the Munich Airport, and we're running the Siemens EDA Automotive Semiconductor Tech Day.
I think, the most important aspect for the European automotive industry going forward is the formation of ecosystems, right? So these actually, are mostly being driven by research technology organizations like IMEC, like Fraunhofer, like LETI in France. And, any of those projects requires an EDA partner, right? Because you need a platform, a software platform that you can actually develop the ecosystem on, right? And Siemens is happy to be part of initiatives with all those three RTOs, and we're very keen on continuing that relationship and contribute to a European-wide ecosystem for the automotive industry.
Given the increasing use of electronics and software in modern vehicles, what we see, of course, is vehicles becoming a potential target for cyber attacks. What that essentially means is functions that are there designed to deliver a certain service may be abused for whatever purpose. And the risks could be to do with safety of the vehicle, to do with some operational disruption, some kind of suboptimal state in the vehicle, some disabling of certain feature, privacy risks, because there could be data that is personal data, or there be behavioral elements that could be essentially exposed, and finally any financial risks as well. Now the challenge, of course, is that vehicles are increasingly connected. They have to be to deliver a number of these services that we talk about, but also they're increasingly complex. They are increasingly carrying this electronics and software in different configurations, coming together to form even more complex ecosystems. So, in a sense, the security of an automotive is becoming quite a substantial challenge. An organization like Siemens, which, given its experience, its breadth, but also its depth, and particularly Siemens EDA, which is where they are positioned with that insight from a number of other industries as well, but also some fundamental core underpinning technologies in terms of system on chip, kind of delivery of low-level monitoring, are very well placed to address this challenge of automotive security. In a sense, we want to be able to have maximum visibility in near real time for us to deploy certain security related controls on vehicles, and that they have to be designed in with technology that is reliable, with technology that is mature, has been proven, demonstrated at least in other sectors, but also with technology that is designed with that very particular purpose in mind, in terms of providing security-related threat detection of a safety critical system.
I think, semiconductor development is the most important factor in the automotive industry, as it's really, the source of differentiation from one brand or one product to another, right? So if you look at the Chinese markets, I've recently read there was a brand that has been including karaoke features in the design, and actually they got bigger market share because of that, right? So this is very truly related to semiconductor design. But in terms of autonomous driving, in terms of safety aspects, I think it's crucial to have be on the edge of semiconductor development.
So modern vehicles increasingly are dependent on various types of electronics and software-driven systems to run for basic safety-critical systems like driving itself, but also a lot of add-on features in terms of in-cabin systems, from infotainment to comfort, to passenger comfort and experience. And that means the semiconductors become the fundamental bedrock over which all of these systems have to be implemented and be running. Therefore, in a sense, from the traditional nuts and bolts and mechanical components, we are moving to a world where semiconductors would be the key component, as it were, spread across the vehicle. And it's also just worth saying A lot of the systems and features and services provided through modern vehicles would be connected. So there'll be cloud-based support, there'll be other devices, personal devices, other devices that are connected to the vehicle from time to time. And they also have to rely on some kinds of electronics or chips or semiconductors that underpin that support. So all in all, semiconductors would be absolutely critical to modern vehicles and ever so more in the future.
So the future for Siemens will be to have this platform. So you can think about, you will have this automotive platform that can be in one layer, doing the link in between all the worlds together, and having models and everything so that we can all talk to each other and really shorten all the time of development. And if then after, because of all the AI developments that are ongoing, you add the AI intelligence on the top of it, then you can further down the road accelerate this development. But the future for the automotive is really to challenge themselves and to stop with the big challenge they have is all the legacy. So it's platforms that are existing, so which is making for existing OEM something complicated because you have to handle the maintenance, you have to think what will change, you cannot disrupt your supply chain or the way you have assembled and developed during many years. So it's a big transformation and they have to transform like Siemens is currently transforming. And it's a big challenge, so that's why with Siemens they can really partner with us to help them with this transformation because it's a digital transformation that we are currently doing.
Well, design for test is important because you're combining silicon of multiple sources, right? So we had the idea of known good dies, but even if you have known good chiplets, you combine them in a whatever architecture on a substrate, it doesn't mean that it's going to work and it's going to work forever. Reliability is a critical aspect in automotive, right? So you really have to plan your reliability up front.